I was talking with a friend last week about the coronavirus, and she noted that many people see the numbers and shrug it off as no big deal. One of the problems I pointed out is that people tend to intuitively see growth as a strictly linear thing and have a hard time mentally accepting just how powerful the mathematics of exponential growth can be. So I decided to make this video to hopefully illustrate this mathematical point in layman's terms. Let's begin with a brain teaser. Imagine you had the opportunity to take a temporary job for 30 days, but instead of getting paid by an exact dollar amount per hour or per day, the employer tells you that you have two options. Option A: each day you get paid double of what you made on the previous day, starting with 1 cent on the first day. And payment option B is each day you get paid $100 more than what you made on the previous day, starting with $100 on the first day. So to further clarify the two options here, with option A, you get paid 1 penny for your first day of work, and then it doubles from there. The second day, you get 2 pennies. On day 3, that doubles and you get paid 4 pennies for working day number 3. Then double that the next day, where you get 8 pennies for working day number 4, and so on, up to and including the 30th day. So that's option A. With option B, your take home pay on day 1 is $100. Then on your second day of work, you get a paycheck this time for $200. Then on the third day, you get a check for $300. Then your pay on day 4 is $400, and so on for 30 days. The question is, which one of these two payment options should you take? How would you like to be paid for your work for 30 days? Now, please don't try to fudge this question by saying, well, I already have a job, or, well, what if you get laid off, or what about taxes and minimum wage? No. Just stick with me here. This is the scenario. We're just going to work with the problem as it's presented. It would seem to many that option B is the obviously better choice. After all, you're making pennies in option A as opposed to being paid hundreds and eventually thousands of dollars each day with option B. But is plan B really the better option of the two, even by the time we reach 30 days of work? If you're like most people, you'll look at the numbers so far, and again, your intuition will tell you, yes, go with plan B. After all, under plan A, the pennies may add up after a while, but they can't add up to that much, can they? Well, intuition is a great thing which helps us with all sorts of day-to-day decision making, but our intuition can be wrong. That's because some things in life can be counterintuitive and yet surprisingly true. There are times we may think that we're thinking rationally and logically, but in reality, we may be going off preconceived notions and biases and rationalizing to get the answers that make us feel the best. That's why we use the scientific method to answer science questions no matter what our gut tells us, or in this case, we're going to use straight mathematics instead of a hunch to answer a math question. Sometimes going with your gut can be the right thing to do, but if our gut tells us one thing and mathematics tells us another, well, then provided that the math is correct and accurate to the problem, then math wins. Now, if you have a spreadsheet and know how to do the math, then you can do what I did and crunch the numbers to see what the payment amounts add up to for 30 days on each of the two plans. Or if you want to get fancy, use the formulas you may have learned back in Algebra 2 for a geometric and arithmetic series. But I'm just going to show you the calculations right now for each of the two options, 5 days at a time. Here's what I got for my spreadsheet. Now, on the left column, we have the workday number. Middle column shows us how much we get paid for that day under Plan A, and the right column shows us how much we get paid for that day under Plan B. So starting with days number 1 through 5 on the job, how much money are we actually getting with scenario A? Well, as mentioned before, with Plan A, we get paid 1 cent the first day, then 2 cents on the second day. Third day, we get 4 cents. Then we just keep repeating the pattern, doubling the previous day's earnings. Doubling 4 cents gives us 8 cents, which is what we get paid on the fourth day, and doubling 8 cents gives us 16 cents. That's what we make on the fifth day. Well, now let's look at payment option B. Instead of getting 1 penny on your first day, you get $100. Then an additional $200 for your second day. Then on your third day, you get a paycheck for $300. Fourth day, you get a paycheck for $400. And finally, on the fifth day, you get paid $500. So if we add up everything for those first 5 days of work, under the first plan, we end up with a grand total of 31 cents, whereas under Plan B, we've earned a total of $1,500. So which is better, option A or option B? Well, $1,500 is way better than 31 cents, so again, it seems obvious that Plan B is better, where we get paid $100 on the first day, and each additional day we get 100 more than what we got paid the day before. But remember, the job goes for 30 days, so let's keep calculating. Let's look at the next 5 days, days number 6 through 10 on the job. In option A, you make 32 cents on your sixth day of work, then 64 cents, and so on like before, always doubling the previous day. We're finally making over $1 a day at some point. But our total for these 5 days of work is still not even $10. Meanwhile, with option B, continuing where we left off from before, you get $600 on your sixth day of work, then get paid an additional $700 on your seventh day of work, then $800, then $900 the next day. And on your 10th day of work, you receive a paycheck for $1,000 just for the work you did on that 10th day alone. And all of this adds up to $4,000 you earned over these last 5 days. And that's not even counting the $1,500 you earned on your first 5 days of work. So scenario B still looks better, no doubt about it. Do we even have to continue? Well, I'm sure to many it seems obvious that B is still the way to go, no question about it, but hang on, let's keep it going. Here are the money amounts you earn for the next 5 days under payment option A and under payment option B, so days 11 through 15. By now, we've calculated everything up to the first 15 days on the job. We're halfway through the 30 days. If you add up the pay for all 15 days so far, you'll find option A will give you $327.67 total by this point, whereas in option B, your 15 days of work have paid you a grand total of $12,000. And once again, you may think, well, this just further proves that B is a better option than A, way better. It's been better so far, so you may be thinking it's going to stay that way. Maybe some of you are even thinking that if we want to just cut to the chase and know how much we'll get at the end of 30 days, we can just stop here and double the numbers that we get so far. Well, that doesn't mathematically work, but let's continue, because something different is going to happen next. We keep doubling the payments every day for option A and keep adding $100 every day for option B. Days 16 through 20 look like this. Notice that on the last day of this run, day 20, for that day alone, our take-home pay under Plan A is up to over $5,000, whereas it's only $2,000 in the second scenario. That seems like a lot more than we might have expected from our plan that started off with paying us, a measly penny for the first day of work and just 31 cents total over the first 5 days. But nevertheless, you can check the math. You're getting more money on day number 20 under Plan A than you are under Plan B. Some of you may be wondering whether this is really significant. Maybe the total amount we get from working all of those days under Plan B will end up being more money. After all, we had all those days where we were making hundreds of dollars in the beginning instead of being paid in pennies with Plan A. Well, is this all true, though? Well, there's only one way to find out for sure. Keep doing the math. Let's look at the rest of the work days. So for the next 5 days, which are days 21 through 25, and then finally the last 5 days of the job, days 26 through 30. As you can see, within the last few days of the 30 days of work, we're making millions of dollars a day with option A, not option B. Yes, the same option A that started off with us making under $1 for each of the first 7 days. When we add up everything we would have earned for all 30 days of work total, we get over $10 million earned with option A. Compare that to the mere $46,500 we would get under option B, which is more money than I make in a month, but still nowhere near $10 million. Thus, the answer to our original question of which payment option to choose is to go with option A. Again, we may get paid very little for the first week or two, but by the end of the 30 days, we make far more money than we would have made under option B. By the way, if we carried this job to 50 days, we would get over $11 trillion with option A, yet only around $127,000 with option B. Even if we changed option B to start with $1,000 on the first day and added $1,000 each additional day, it still wouldn't add up to the trillions of dollars you would get under option A doing that for 50 days. I don't know about you, but I could certainly put up with getting paid pennies my first week or two of work if the option meant that I would be a trillionaire in under 2 months. And that illustrates the power of exponential growth, or geometric growth as it's sometimes called, growth that multiplies upon itself. Not only do the numbers increase, but the speed at which those numbers increase is increasing as well. Compare that to Plan B, which we would call linear growth or algebraic growth, where the amount goes up, but the rate remains the same. The moral of the story is that exponential growth grows deceptively much faster than linear growth in the long run. When we look at a list of growing numbers, we still tend to think of the growth in the linear way. That's how we mentally picture it, not the exponential way. And that's probably because in most of the day-to-day numbers that we work with, it's linear and not exponential. We add 1 to our ages every year when we have a birthday. We can think of how much money we'll be paying in a year for a car loan if we take the monthly amount that we're paying and just multiply by 12, and so on. But as we saw with the 30-day work analogy, exponential growth doesn't really work like that. It grows much faster because we're not just adding the same number each time, we're multiplying. It grows at an ever increasing rate, not a steady rate. The growth may look really slow at first and give us seemingly low answers, but it doesn't take too long for the numbers to explode. Somebody looking at just the numbers from our word problem may see that drastic difference between the start and end and think, hey, what's different about day 19? That's when the pay for option A became greater for that of option B. Why is that? What changed on the job around that time? And the answer is nothing changed. In our word problem, nothing changed about the job. Nothing changed with the way we got paid. Nothing changed with the math formulas. That's just the result we got from the math and the math alone. Likewise, when you look at a graph of an exponential curve, you may see a point on the curve where things seem to shoot straight up. And intuitively, you may think that this means there was something different or special that happened at that point. You may look at a graph on how a certain statistic changed over the past 100 or 1,000 years and see what looks like a sudden increase and think that, well, that point marks a special historical event, or the introduction of some piece of technology, or some particular government action, or something else responsible for changing the rate of growth of whatever is being measured. Maybe, but maybe not. You may just be looking at nothing more than the natural shape of an exponential curve. Again, in our case, there was nothing inherently special that happened around workday number 19 that made the pay of option A overtake that of option B. The work didn't change, the formulas didn't change, that's just where the math itself took us. Before I finish, it's worth pointing out that not every type of growth is necessarily one of these two forms. Oftentimes, there are more factors which complicate the calculations. Sometimes rates fluctuate in other ways. And with some phenomena, rates simply slow down over time. Take human height, for example. A boy may be 2 feet tall by the time he's old enough to walk around the house, and say 4 feet tall at some point when he's in grammar school, but that doesn't mean he's going to be over 8 feet tall by the time he's an adult. That's because the rate eventually slows down. When it comes to highly contagious diseases, though, we have seen in the past the very fast effects of exponential growth, the same with economic decay for that matter. Things not rising or falling steadily, but moving up or down at an exponential speed once you step back and look at the changes over a long period of time. These things can happen much quicker than your mind may expect them to happen. The moral of the story is that just because something seems intuitively correct doesn't necessarily mean that it's factually correct. And looking at exponential growth, especially when you're looking at a very small part of it near the start, can be mistaken for linear growth. You need more data to figure out which is which. As I'm recording this clip in March of 2020, a lot of people are upset with the measures to shut down jobs and large gatherings in order to quarantine people, especially when they may look at certain death numbers in a region go from, say, 20 to 100 and still see these numbers as very low and not really a cause for concern. Some have even dismissed the whole thing as an overblown hoax and ignore the advice to practice social distancing. Granted, we can't always predict long term trends with tremendous accuracy, and even the worst disease epidemics reached a point where the rates of growth slowed down eventually. But we do know that exponential growth happens in nature and it is deceptively fast. In my opinion, we can't afford to dismiss the spread of a deadly virus as linear, when it may more accurately be exponential, as has been the case with past epidemics. The earlier action we take, the better chance we have of slowing down and stopping that rate of growth, altering that curve so it doesn't grow out of control. The key to stopping huge numbers of exponential growth in the future is limiting how fast it grows in the present. As the old saying goes, an ounce of prevention is worth a pound of cure.